Hello everyone, Mr. Fawcett here, and we are back for another Algebra 1 lesson. Today we're going to focus on order of operations, and while it's something you have probably talked about pretty heavily in your pre-algebra or middle school math courses, it's something that is extremely important moving forward, and we want to have a very good grasp and very good efficiency using order of operations before we start solving equations. So we do order of operations, we get those down pat, and then we start moving in and solving equations with some different variables. So today we're going to talk about obviously the order of operations, which you've studied before. I'm sure everyone has heard, please excuse my dear Aunt Sally, or PEMDAS, or something along those lines. But we're gonna go a little further than that and do quite a bit of example problems where we just talk about our options with order of operations and talk about the different nuances and the ways problems may be written that may throw you off if you aren't careful. So plenty of example problems today, and then you'll have plenty of problems to also practice on your own. So before we start doing any problems, let's go and just quickly review the order of operations. So first, we always want to look for those parentheses. Sometimes they're not specifically drawn into the problem, and we'll talk about examples where we can draw in our own parentheses to make sure that we simplify those quantities first. After parentheses, we move on to exponents. Number 3, it's both. It's multiplication and division, and this is sometimes the problem with please excuse my dear Aunt Sally or PEMDAS is that the M always comes first in those acronyms. So we have to be careful. It's multiplication or division, whatever comes first as we move from left to right in the problem. Okay, so we may end up doing division before multiplication if that comes before multiplication in the problem. Then we have addition and subtraction. Same idea. In both the acronyms, the A always tends to come before the S, but it's really just whatever comes first as far as left to right goes. So again, it could be subtraction before addition. It just matters what is coming first. Okay, let's go back over and just jump right into some problems, because the best way for you to understand these order of operations is just to get some practice. I would encourage you to try these problems on your own first. I will give you the numbers that we're going to do on each page, so you can feel free to work through those and then come back and watch the video. I think that's the best way to see what you remember from pre-algebra and other math courses you may have taken. So again, we're going to do numbers 1 and 2 together from the first page, but I encourage you to try those before we go over them. Okay, let's look at number 1. So we see two sets of parentheses, and with parentheses we can work our way from the inside one to the outside one. So we can think, is there anything for us to substitute about -7? There's not, so we're going to jump out to the outer set. Now we have -7 minus 9. Well, -7 minus 9 is going to give us -16. So this is equal to 3 minus, and then in parentheses we have -16. Right here I'm subtracting a negative number, so there's nothing else for me to do inside parentheses. But it's 3 minus -16, which ends up becoming 3 plus 16. Remember, when you're subtracting a negative, that's really like adding the number. And then 3 plus 16 is 19. So we are done with number 1. On to number 2, we do see an exponent, but remember we are going to do parentheses before exponents. So this means we're going to do -1 minus 2, which is going to give us -3 squared. Remember what exponents do. Exponent just means we multiply the number by itself that many times. So what this is really saying is -3 times -3. That is what -3 squared is telling us to do. A negative times a negative, that is going to give us a positive. So we have +9 as our answer. Common mistake is for students just to multiply the base, which is here, by the exponent. So they may just get -6, or they may get 6. But again, the exponent means multiply the number by itself, or multiply the base by itself that number of times. Okay, we are going to move on to number 6 and number 8. So you may want to take a look at those and then hop back here for the explanation. Number 6 and 8. Okay, for number 6, we have a quotient. So here's the thing. When you have a fraction or a quotient, you can put parentheses around the entire numerator and the entire denominator, because that's what you really want to simplify first. You want to simplify the numerator and the denominator before you do any dividing. So I know there's nothing to simplify in the numerator, it's just 20, but we can simplify the denominator. So I have a negative sign. Something else to talk about is this negative sign can either go to the numerator or it can go to the denominator. It just can't go to both. Or you can leave it until the very end and just put it into the end. So it's up to you. I could leave this as -20 over my denominator, or I'm just going to show you all the different ways. Or I could have 20 divided by negative, and then in parentheses I have -2 plus 7. So I could put in my denominator. Or I could just leave it where it's at on the outside of the fraction and worry about it at the end. And we can just do that for now. So in my denominator, I have -2 plus 7. That's going to give me a +5. -2 plus 7 gives me a +5. 20 divided by 5 gives me 4, and I'm going to keep my negative. So my answer is -4. Okay, on to number 8. Okay, some more exponents, but this time we have a fraction with our exponent. So there's two ways to approach this. I do want to talk about what it means to have a exponent on a fraction. Knowing that though, given operations, we could simplify the parentheses first, and that actually makes it a lot easier. So I'm going to do it that way, and then I'm going to go back and show you how we would simplify this if we attempted the exponent first, which is, it's allowed here, it just makes it more difficult. So if I simplify what's inside parentheses, -27 divided by -9, negative divided by negative gives me a positive, and that's going to give me 3 inside my parentheses, 27 divided by 9. Square the 3, so that just means I'm going to have 3 times 3, which is equal to 9. Of course, you can just jump straight from this step to this step. I'm just writing out what the exponent means for a refresher. Okay, let's say I want to show you the other way we could do this. It's going to look a lot more complicated, but there's a key concept in there that can be applied to later problems. However, the way we just did it would obviously be the easiest. What an exponent means, as I stated from above, is that it tells you how many times you need to multiply the base by itself. So this would really equal -27 divided by -9 times itself twice. So times -27 divided by -9. So this is where order of operations can be a little tricky, right? This is perfectly legal in the realm of math. I am allowed to simplify the exponent, so rewrite the expression without an exponent before I simplify what's inside of my parentheses. I haven't changed anything. I've just rewritten the problem in a different format. So in this case, the way we wrote it, now we have two options. We could either simplify what's inside parentheses. So we could say -27 divided by -9 gives me +3. And that's going to be the same inside both. 3 times 3 gives me 9. So again, same answer as I got above, or during the first time. A little more complicated though, I think. This next way is going to be even more complicated. So instead of simplifying inside parentheses first, I could multiply. I could multiply my negative 27 by my negative 27 because remember when you're multiplying fractions, we multiply straight across. Numerator times numerator, denominator times denominator. So negative 27 times negative 27 gives me positive 729, and negative 9 times negative 9 gives me 81. Now, you're probably going to have to use a calculator here because it's not clear what 729 divided by 81 is, but if you punch that in, this would also be equal to 9. Again, some ways tougher than others, right? It would also be pretty tough to do negative 27 times negative 27 in your head. So if you had no access to a calculator in this problem, you would probably want to do it one of the first two ways, right? And not try it this last way. But all of these ways are valid, okay? We haven't broken any mathematical rules. The next problem we're going to work on is 11. So if you want to pause the video and go to 11 and attempt it, then come back, that would be ideal. All right, so with number 11, we have a new symbol here. This is the absolute value symbol. That's what these straight up and down segments or bars are. Okay. If we think back to absolute value, the absolute value just tells us to make whatever is inside positive. Without going into too much more detail, absolute value is just the distance that a number is from 0 on the number line. So if I have negative 4 and 4, both of these have a distance of 4 from 0, which is why the absolute value of negative 4 equals 4, and the absolute value of 4 equals 4. Again, I'm sure you've talked about that in previous classes, but just a little refresher. The absolute value signs just tell us to make whatever's inside, after we simplify it, positive. Okay, so for number 11, I'm going to get rid of, actually I don't have to get rid of that. So whenever we have a fraction, remember I said you can put parentheses around your numerator and around your denominator. Denominator already has parentheses inside of the absolute value, so we can leave it. So if I simplify my numerator, 28 minus 8 is 20. The absolute value of negative 10 is positive 10. We just make it positive. And 20 divided by 10 is 2. Okay, on to 12. This just looks like a lot of subtraction here going on. So I want to look at my parentheses first. So there's nothing to simplify about the negative 2, so we don't have to worry about that. So I get 3 minus, and then in parentheses I have negative 2 minus 9 minus 2. So negative 2 minus 9 is negative 11 minus 2. Simplify inside of my parentheses again, so minus negative 11 minus 2 is negative 13. Then I'm doing 3 minus negative 13. So I'm really just adding 13 to 3. So I get 3 plus 13, which is equal to 16. All right. Next one we are doing is, oops, I didn't even say we were going to do 12, but I guess we did anyway. You got a freebie. Next problem we're doing is, I believe, 15. Let's clear this, although we might skip 15 because we just did 12. We'll do 15. That's okay. You'll still have plenty to practice on your own. So 15, we see a fraction, and we're going to look to simplify that before we do any addition or subtraction. So I get negative 1 plus 8. I don't have to keep the parentheses there because there's nothing to simplify inside the parentheses. It's just negative 1. So once you've simplified what's inside of the parentheses, or if you're unable to simplify it, then you can well, if it's just one term, you can take the parentheses away, and -1 is just a single term. 2 divided by -2. That's going to simplify to a whole number, and it's going to simplify to -1. 2 divided by -2 is -1. Notice I also have this negative sign in front of the fraction, so I also have to bring that down as well. Now, remember we said addition and subtraction occur in order from left to right. So I first have to worry about the -1 plus 8. That's going to give me +7 minus -1. Okay, if you do 8 minus -1 first, you may end up getting a different answer at the very end of your problem. So here I have 7 minus -1, which is really 7 plus 1, and that gives me 8. Before we go on, I do want to show you why you have to go in order left to right, because you may say, Mr. Fawcett, in this problem wouldn't have mattered if I had done 8 minus -1, if I had done this first and then done -1 plus 9. You're right. In this problem, it wouldn't matter. However, I can give you a couple problems where it would. So if I had the problem 8 minus 2 minus 1. Okay, if I go from left to right, so that's going to give me 6 minus 1, which is going to give me 5. I get 5. That's the correct answer because we went left to right. If I do it another way, let's do it in blue. So if I do, oops, let me get my pen. So if I have 8 minus 2 minus 1, and I don't do it from left to right. So if I do, and there's, again, a couple different ways you can do this. I could just do 2 minus 1, which is 1. So I could do 8 minus 1. That gives me 7, which we know is not correct because our answer is supposed to be 5. Or maybe you did it this way. Maybe you actually kept the negative with the 2. So you have 8 plus -3, which ends up giving us 5, which does end up being correct. But here's the thing. If you don't do it from left to right, then you may or may not get the correct answer. And it has to do with what signs are where in the problem. But you don't want to have to memorize like which sign's a negative, which sign's a positive. Okay, I can do it in whatever order I want, versus now I have to do it left to right. You always just want to do your addition and subtraction left to right. That will always get you the correct answer. If you don't do it from left to right and you just kind of pick and choose, then you may get the right answer like we did over here, but you may get the wrong answer like we did here. So stick from left to right. That will always get you the correct answer. Okay, onwards to 18. Okay, so 18, we have a fraction and an exponent, but it's just in the denominator. Again, you should be trying these on your own before you take a look at the video, just a reminder. Here, remember, when we have a fraction, we want to simplify the numerator, simplify the denominator, and then do our division. So the numerator can't be simplified. It's just 1. The denominator has a couple things going on. It has a set of parentheses, and then it has the exponent. Let's simplify what's inside parentheses first, and then we will worry about the exponent. Inside the parentheses, we have -2 plus 1. That is going to give us -1. I'm going to do this off to the side, this exponent expression. This time our exponent's 3. So -1 cubed is equal to -1 times -1. And maybe it's easier if I just put it in parentheses so you don't get confused with the negatives and the multiplication symbols. So that is what -1 cubed looks like. -1 times 1 is +1. Then we still have the extra -1. 1 times -1 is -1. So this expression right here becomes negative 1 over negative 1. 1 divided by negative 1 is negative 1, so I get negative or minus negative 1, which is equal to positive 1, because I'm subtracting a negative number. There were a lot of ones, there were a lot of negative ones here, a lot of negative signs, so we really have to make sure we keep them straight. And then we also have to, again, understand the rules of exponents as well. Okay, looks like we are doing number 21 next. This is going to be a two-part video, by the way. We are not going to get through all the ones that I want to in one video. Second video will be the tougher problems. So we're going down to 21. These are actually grouped in sections of 10. So the first 10 problems were what I thought were the easiest ones. The next 10 were a little tougher. The next 10 a little tougher. And the last ones, as you'll see, they're going to seem pretty tough when you first look at them. But I think working through a couple and you'll start to be able to figure them out. 21, again, here it's a little different because we have a fraction, but then we have an integer next to it that we have to add to it. So let's start off by simplifying the numerator and the... Oh, that's not going to be good for the gray. Let's do a light color so we can see. So this is going to be equal... Oh, still need my pen. All right, there we go. So this is going to be equal to 2 plus what's in my numerator and what's left in my denominator. So in my numerator, I have 23 minus negative 1, which is really 23 plus 1. In my denominator, I think it's pretty clear 4 minus 1 is 3. Let's write one more line. In my numerator, I think it's clear that that's 24. In my denominator, we have 3. Before I do any subtraction, let's do the division. So I get 2 plus 24 divided by 3, which is 8. And then 2 plus 8 is equal to 10. So we get 10 here as well. Guys, a lot of times, so these order of operation rules are not strict rules. You don't have to always follow what they're saying. A lot of times it just makes it easier. For instance, in this step right here, right, we could have done addition, right? We did not have to do division here first. However, had we tried to add these two together, we would have had to find a common denominator, which would make it, fairly difficult, or not I guess fairly difficult, but more work than dividing 24 by 3, right? So if we had to find a common denominator, we may get 6 thirds, because 6 thirds is equal to 2, plus 24 thirds, which would give us 30 thirds, which would give us 10, right? So we ended up with the same answer. We just had to approach it. Differently. So again, the order of operations, it helps you know what's going to be the easiest path. Sometimes there are hard rules that you have to follow, right? Like you have to do your addition and subtraction left to right, unless you want to be unsure of whether your answer is correct. But there's other times, right, where we have the option, like with exponents. We can either get rid of the exponent first, or we can do what's inside parentheses first. Or right here, we can add the two terms first, and then we can divide, or we can divide first and then add. Onward we go to 25. This may be the last problem for this video. Okay, a lot of parentheses here, but overall it shouldn't be too bad. We'll use green this time. Although I'll keep it on one page, so we don't have to. Let's do black. So here we have two sets of parentheses. We have this 4 minus negative 9 in one, and then we have a fraction in the other. So we're going to try to simplify both sets before we multiply them together. So 4 minus negative 9 is really just 4 plus 9 because I'm subtracting a negative. I have my fraction in my other set of parentheses. My 20 can't be simplified, so that stays. 2 minus 7 is negative 5. Okay, good so far. 4 plus 9 is 13. In parentheses, I have negative. 20 divided by negative 5 is negative 4. Whenever I have two negatives back to back, I like to just put parentheses around my one number. I think it looks a little easier. I think it's a little easier to look at, and we're less likely to make a mistake. So I have 13, and then if I have two negatives, so minus negative 4, that's going to be plus 4, positive 4, and then 13 times 4 is 52. So 52 is our correct answer here. Let's see, we have 1, 2, 3, 4, 5 for next video. Let's see if 28 is a short one. No, so we're going to pause the video here. We'll come back for part 2, and we'll look at some of the more difficult ones in this packet. I would feel free to go back and do all the ones up until this point, because I think I gave you the tools, or at least reviewed the tools with you on how to correctly simplify those. If you have any questions, please write them down so that we can discuss them at our next meeting. Okay, enjoy the rest of your day, and I look forward to seeing you next video.